In this installment of Basic Structures, we're going to talk about simple box structures. So this is a really straightforward structure, but incredibly versatile and sort of somewhat underrated. So this is two base plates and two verticals. So I'll start out by drawing the base plate that'll live kind of at the top of the box and draw the verticals in here. So obviously I'm speeding up the video a little bit to kind of go through a little bit more quickly than some of the previous videos. Okay, so I've got four sort of flat pieces arranged in the two verticals and two base plates configuration. Add my cutout lines, and I've noted in the notes up here that its box is strong in compression, but maybe not so great in shear. So what does that mean? Well, if we load the top of the box directly, we set a load just straight down on it. Right, compressing those vertical plates is very difficult to do. So the box is pretty stiff for just a direct force straight down on the box, assuming that's sitting on something fairly rigid. But in shear, so if we kind of put a force pointed to the right on the top base plate of the box and then counter that with a force pointed to the left on the bottom plate, right, this whole thing is going to shift and kind of skew sideways, right? So if you've ever assembled bookshelves, before you put the backing plate on the bookshelves, right, they kind of want to wobble back and forth. So we need some way of stiffening up the box. So as you've probably anticipated based on the previous tutorials on structures, right, the first option might be to do something like add dado joints that connect the verticals to the base plates. And so that'll give us a little bit of mechanical interlocking between the vertical members and the base plates. And that'll be a bit stiffer than if the edges of the verticals just met with the edge or the surfaces of the base plates in a kind of a flush way. So I got my dado joints in there. And I might like to, I don't know, reinforce those with some glue or maybe some machine screws, let's say, or some self-tapping wood or plastic screws, depending on the material I'm working with. Right, so next up, if you've been following along in the other structures videos, you could probably anticipate that, well, if we want to stiffen the box even more, we might consider trying to construct the whole thing using welding, right? If this is a metal part, that would be one convenient way to make a very stiff box. So I've got vertical plates, base plates, and then I'm kind of sketching in these exaggerated welds that are sort of rounded and sketching in some lines to indicate their curvature. Maybe I'll put in the symbol demonstrating that the welds extend down the seam on both sides and finish up with some cutout lines. The last structure I'll draw in the sort of box family is kind of a funny structure. It's more box-like, I would say, than sort of actually being a box. And this is a structure that's sometimes referred to as a clock cage. So rather than vertical plates, we could use some vertical members like rods and connect those rods to horizontal base plates, for example, using maybe machine screws if the rods are tapped. And the clock cage has the advantage of being really very stiff in just about every direction, particularly if it's reinforced with machine screws rather than just sort of press fitting those support columns in. Finally, one major advantage of the clock cage is that it's open on the inside. So if you have a mechanism or parts inside, you can easily access them and maybe get some tools in there if you need to work on it.